This video is going to finish the 9.6 homework. Starting with number 8, we have the length of AR is 40 pi centimeters and CA is parallel to RE. So these are parallel. Well, that's automatically going to tell us that arc AR is congruent to arc CE. Because of the parallel lines, what was that? Parallel lines intercepted arcs conjecture. That's conjecture 85. So if I call this x, this would also be x. That would mean that 2x plus 70 plus 146 would equal 360 degrees. So 2x plus 216 equals 360. Minus 216 from both sides, that would be 144. So x would be equal to 72. And that's going to mean we're trying to find the radius, and we know the arc length is 40 pi. So 40 pi times equals, 72 over 360 times 2 pi r. And we'll just solve for r. So 40 equals 144 over 360 times r. Divide both sides by pi. 2 times 72 is 144. Multiply both sides with a reciprocal, and you will get 40 times 360 over 144 equals r. So 100 equals r. So you want to put units on that number. There we go. So the radius is 100 centimeters. Okay, let's go ahead and do number 9 now. A go-kart racetrack has 100-meter straightaways and semicircular ends with diameters of 40 meters. Calculate the average speed in meters per minute of a go-kart if it completes 4 laps in 6 minutes. Round your answer to the nearest meters per minute. So let's go ahead and draw a picture. You got a semicircle, got 2 straightaways and a semicircle, and we got a 40-meter diameter, and each straightaway is 100 meters. So the question is, how far does he travel if he goes 1 lap? Okay, so for 1 lap, that would be 100 plus 100 plus 40 pi, because that's the diameter, or pardon me, that's the circumference of the circle, which could either be 2 pi r or pi d. In this case, the diameter is 40. You have 2 semicircles with the whole circle, so that's going to be 40 pi. So that he goes 4 laps. So the total distance is 4 times 100 plus 100 plus 40 pi. And that's going to be 4 times 200 plus 40 pi. And he goes 4 laps in 6 minutes. And so then when you do the math, you'll get about 217 meters per minute. Okay. Number 12. Recall that the radian measure is calculated by finding the ratio of the arc length to the radius. How does the size of the circle affect the radian measure? How does the central angle affect the radian measure? Calculate the radian measure for these three 45-degree angles and write a conjecture for your results. Use different central angles, test your conjecture. So, all right, first step, how does the size affect the radian measure? Let's go ahead and calculate the radian measure for each of these. The radian measure, again, is the arc length divided by the radius. And so that's going to be 45 over 360 times 2 pi r times r. And this is 45 over 360 times 2 pi r divided by r. And 45 divided by 360 times 2 pi r over r. Well, I immediately notice that the r's cancel. And so I'm left with 45 over 360 times 2 pi, 45 over 360 times 2 pi, and 45 over 360 times 2 pi. Well, I can go ahead and simplify this because I have a 2 here, and that will change this to 180. So that's 45 over 180 pi, 45 over 180 pi, 45 over 180 pi. Okay. Well, it looks like the radius doesn't change the radian measure. So no matter if the radius is 6, 12, or 10, you still get the same radian measure. I notice the central angle does affect it. So central angle definitely, if that were to change, these would change. I also notice that these are all basically 45 times pi over 180. So it kind of looks like to me you're multiplying 45 by pi over 180. And that would be my conjecture. To multiply pi over 180 times central angle to get the radian measure. Okay, let's go ahead and do 15 now. So earlier in this lesson, in exercise set, you found that the radian measure for a 120-degree arc was 2 pi over 3 radians, and for a 45-degree arc was pi over 4 radians. What is the radian measure for a semicircle? What about a complete circle? So again, if we go back, notice how each of these here could be simplified down to pi over 4. So all of these equal pi over 4. Each one of these, if you simplify it, because 45 over 180 is 1/4. That's all pi over 4. And 2 pi over 3 came from earlier in the lesson. And so what about for a semicircle? Well, a semicircle is, if you think about it, that's 180 over 360 times 2 pi r. And that's your arc length. Because the radian is the arc length divided by the radius, which is going to be r. And so that's going to be 180 over 360 times 2 pi, if my r's cancel. And that will end up being just pi. Oh. So the radian measure for a semicircle, is just pi. What about a complete circle? Well, complete circle is just 2 pi r over r, which is just 2 pi. And so you will find in Algebra 2 that for a half circle, the radian measure is pi. For a full circle, it's 2 pi. For a 45 degrees, it's pi over 4. 90 degrees is pi over 2. And so on and so forth. That concludes 9.6 homework.